r by 2. The density of this is rho. Now I want all the points. I want the field, say at point P1, P, everywhere. So what is again OP1, O1 P1 is equal to say 2R. O2 P is equal to R by 4. So find the field. So in place of cavity, what you have? A sphere of density 2 rho. It can be asked like this also, no? So it's not a cavity. The green color is not a cavity. So how do this is obtained? First, in a sphere of radius r and density rho, I will form a cavity. In that cavity, I'll fill up with a density of material of 2 rho. So I should not call the green color as a cavity, no. It's having a more density. What you are going to do? Say nothing but shall I say like this is equal to like a sphere without any cavity of density rho plus a sphere of density rho at that particular point. Reverse thinking. Say good logic will go for it. So what this is equal to? I need that green color one. So some. Now you see this. See, all these are unlimited way of asking things. So if you can get that trick, no, I think you can manage. So what I am asking you to assume is, this is a density rho, everywhere density rho. This again a density rho. Sir, what is this 2 rho you brought it? No, this one you go and keep it here. So what you get here? In this region, plus rho, you'll get 2 rho. Got the idea? In books, what pen we don't have much description like this. I just picked up a problem. Now, what is the field strength here? E1. What is the field strength here? E2. And what you calculate, that is EP1. So what is EP1? But sir, we don't know mass. As you know density, you can express in terms of mass, or in terms of density of sphere, you can bring the answer. Okay, let's assume that the mass of this BM1, this BM2. So what is the formula? GM1 O1 P1 whole square GM2 O2 P1 whole square. G into O1 P1 is 2R whole square, and O2 P2 O2 P1 O2 P1 should be 3R by 2 whole square. So what is M1? Rho into 4 by 3 pi R cube. G into O2 P is what? 3R by 2 whole square. Four by 3 pi R by 2 whole cube. Why R by 2? Radius of this is how much? R by 2, and density is rho. But sir, you said density 2 rho. Look at the diagram. How do you get this? Sphere of density rho. There, if I bring another sphere of density rho and I fix it up in this region, what do we get? I get a density 2 rho, remaining part only rho. It's only about calculation. 4 by 3 pi R cube, I think I can take outside. G rho, 1 R square will get eliminated, R square. So 4 G rho. Shall I take this much for time being? So this will be 1 by 4 plus. Anybody value here? 4 by 3 pi, we took it outside, no? 1, 4 will come, 4, 4, this will be 3 square 9 into this is 8. 4 1 ja, 4 2 ja 8, 18 will come, this is. Check calculation, it's row only. Don't look at two row. You look at this diagram. This two are equal to this one. This plus this is what this. Here row is there, no? If you bring this row also, it become two row in this region. This what? Don't write two row here. I'll keep with the red color at least. It should be row only, not two row. And I'll write plus row again. Okay, fine. Anybody value? And I'll go for next problem if you give me the value.
Sir, by r cube, r square, sir.
Okay, here I'll make it R.
Sir, 11 by 27 G rho pi r.
11 by 27 G rho pi R. There's a field at point P1. Now how to calculate the field at point P? The point P will come here, no? The point P is here, and the point P will somewhere here. We have given O2P also value given. Look at here, O2P R by 4. Now what shall we do? Again the same vector method. Field inside the cavity. This point P, I'll show it. So what is the formula? I think we have derived formula, no? 4 pi by 3 rho G R. What is small r? The distance from where you are calculating. 4 by 3 pi rho G R. Last one, look at again. So what is the field? Field at point P. The field at point P will be given by EP dash EP dash EP double dash, I'll write it. I'll draw one diagram. Not everything we can't mess up here. Same diagrams are there, no? Same thing will take it. Yeah. Copy. Let's get into the problem. Okay, these things calculation not needed. Already we have calculated, no? Just take it out. Because our point now is inside. We have to focus inside the sphere. So there's a point P. So in this diagram, can you show what is O1P? P like the field. Shall we write this is E1? Now, is it a positive density? Is it a positive density or negative density? It's a positive density. How the field should be towards center. So I just picked up this problem so that students can really make a difference. Sir, there earlier it was O2P. Now you are bringing it that PO2. Yes, it should be that one. What is E1? Looking at the diagram, what is E1? Anybody? Can you write E1? E1 should be 4 by 3 pi G. Density is how much? Rho. into what is the distance? Distance will be PO1 bar. That's smaller, no? That formula. And similarly, what is E2? 4 by 3 pi G. Shall I write 2 row or row? No, better write row only. We are doing for this. See, this is equal to sum of these two. Huh? So I'll bring it here. At least agreed, no? This particular left hand diagram is equal to sum of these two. I should add up these two. What is now we should write this as PO2 bar. But sir, you wrote O2P if it were cavity, but it's having a density plus rho. Okay, let's take the vector sum. So if you understand, it will be PO1 bar plus PO2 bar. Substitution E equal to E1 bar plus E2 bar. Okay, see all this. Now we know value, no? What is PO1? PO1, okay, the values are not given, no? PO1. Yeah, keep it like this here. So, but what is the vector sum of these two? Shall I take difference or shall I add up? Shall we add up or shall we take difference here? We should add up only because E2 is positive, E1 is positive. The E1 bar plus E2 bar is what? The required answer. I think a little bit carefully you have to be that one. If I give the distance O1P, O2P is how much it is? R by 4. It should be a little bit greater than that. I'll give that O1P value also. O1P, let it be R by 3. Possible? Huh? This is R by 2. It should be more than that. Yeah, 2R by 3. O1P, that one. So substitute that value. But we have to substitute with vector diagram. Huh? Vector sign, not just magnitude. Not just magnitude here. So the resultant vector, this is E1 bar, this is something E2 bar. The resultant vector will come somewhere here like this. Fine. So these are the types of numerical. Now, will it be uniform? No, it will not be uniform. Because as you change the distance, as you change the point P, what happened to this bracket term will change, no? So will not be uniform. But sir, in cavity it was uniform. Getting, no? So you may get cavity or particular region where the density will be 2 rho. It's, I think it's a solid sphere. Both are not a disk or something, that to make it clear. So there's a sphere of density rho, there's a sphere of density rho of radius r by 2. When I place it, superimpose, we'll get this diagram. Okay, fine. So these are the some types of numericals what you can expect in exams. Okay, now what about outside? Outside will be very easy, no, to find out. If they ask you outside, it's very easy. If they ask you somewhere a point here, it's quite very easy. We know field due to this. If I ask you somewhere here, you can find out field here. If I ask you to due to this, will be here. Take superposition, you get the required answer. The vector sum is what you should take help of it here. Okay, this is about the overall idea of the cavity. Now you may get a cavity in a very large sheet. Let me test you. So this is the XY plane. Okay, to